Welcome back to the deep dive. This is where we take your source material, your training docs, your research, your briefings, and we just cut right through the noise to get to the core of what you need to know. Fast. Today, we're getting into something that sounds, kind of basic, but where getting it wrong could be, well,
hmm
catastrophic. We're talking about the fundamentals of workplace respiratory protection. We've gone through your mandatory training materials, and our mission is simple: to pull out the high-impact facts, the critical steps. If you're prepping for this training, this is your shortcut. Okay, so let's unpack this. If we just strip everything else away, all the regulations, all the procedures in these documents, what's the one single goal here?
the sources define that mission with
Yeah.
with total clarity, and that's really why this training is mandatory.
Right.
The primary purpose, the ultimate reason for every single rule is it's really direct. It is to prevent respiratory-related illnesses and to keep employees safe.
That's it. A protective, non-negotiable goal.
Exactly. Everything else, all the gear, the monitoring, it's just scaffolding
Oh,
built
yeah.
around that one objective.
But that simplicity feels a little deceptive, doesn't it? If the goal is just prevent illness, how do the documents handle the huge trade-offs? I mean, safety costs time, it costs money.
It handles them by focusing on structure, on early prevention, because you can't prevent what you haven't identified.
Okay.
So that's why the sources immediately go from the goal right to the threat. To be safe, the training has to make sure employees understand the risks of exposure to hazardous substances.
Mm,
They even break them down.
exactly. So to protect ourselves, we have to know what we're fighting. What are the specific categories of hazards these training docs keep bringing up?
They're very specific. They focus on three main material risks that can hit your respiratory system: dust, fumes, or chemicals.
And they're not all the same thing.
Not at all. And understanding the difference is, where the real knowledge comes in. For instance, think about dust versus a fume. Dust usually comes from mechanical things: grinding, sanding, cutting. They're just irregular particles.
Yeah.
But the sources define fumes as these tiny, solid particles created when a solid, usually metal, is heated way up,
Mm.
boils, and then cools and condenses.
Like welding.
Welding is the classic example. It produces fumes.
So a fume is basically a resolidified vapor. It's
Yeah.
tiny, it's highly concentrated. Okay, so then why is the third category, chemicals, so broad? Doesn't that kind of cover everything?
It covers the gaseous threats, the vapors. The training is forcing you to see the difference between particulates and, well, non-particulates. A chemical vapor, for example, is the gas form of something that's normally a liquid.
Like a solvent?
The solvent, certain adhesives, yeah, you can't see it, but it's there, acting just like an invisible gas.
And that distinction is critical.
It's everything, because if you use, say, a standard P100 particulate filter, which is great for dust and fumes, against an invisible chemical vapor, you get zero protection. The vapor just goes right through. So the sources are stressing that, success starts with getting the risk identification right. If you misidentify the hazard, that's the first catastrophic failure in the whole safety chain.
And that's where context is king. It's not just knowing the equipment exists, but knowing which filter or which cartridge you need for a specific hazard.
Precisely. And the standard used to measure if that protection is even working is the permissible exposure limit, or PEL.
The PEL.
Right? It's this foundational metric. It's the legal max concentration of a substance you can be exposed to over typically an 8-hour workday. The entire point of the training is to keep you below that PEL.
That makes sense. It's not about feelings, it's about measurable compliance. And your notes also say this topic has significant overlap with other workplace safety training topics. It's not isolated.
That's a key point. Respiratory safety intersects with hazard communication training, for instance. You have to read the safety data sheets, the SDS, to know if you're even dealing with a fume or a vapor. It's also tied into emergency protocols, material handling. If you fail one, you compromise the whole system.
So if that's the threat, then the next question has to be about the physical lines of defense. And here's where it gets really interesting for me. Because, having the tools is one thing. Knowing how to use them, that's the hard part. So we've identified the threats: dust, fumes, chemicals. Now, what about the toolkit? What equipment is the focus?
The training documents really boil it down to one key requirement: mastering the proper use of respiratory protection equipment. It's all about competence, not just having the gear.
And the gear is?
The sources specifically cite masks or respirators. But that phrase, proper use, that's everything.
Explain that.
Okay, think about it. A respirator is designed to create a totally sealed environment around your nose and mouth. If that seal fails, even by a tiny bit,
Air is going to find a way in.
it'll follow the path of least resistance. which means the hazardous air gets pulled right into your breathing zone, completely bypassing the filter.
So a $300 respirator is basically worthless if the seal is broken. The failure isn't the tech, it's the person. It's the pre-use checks.
Exactly. And that is why the training mandates specific procedures, like fit testing and seal checks. And for you, the listener, understanding the difference between those two, that's a common point of confusion.
Okay, yeah, let's dive into that. A fit test versus a seal check. What's the difference?
A fit test is the formal process. It's done periodically, and it confirms the mask actually fits the shape of your face. The training covers two main types, qualitative and quantitative.
Qualitative versus quantitative.
Right, a qualitative fit test is subjective, it's a pass-fail. The common one is where they put a hood over your head and spray a sweet or bitter mist in there, like saccharin.
And if you taste it...
If you taste it, the mask has failed. The seal isn't good enough. It relies on your senses.
Okay, so what's a quantitative test?
A quantitative fit test is completely objective. It's precise. It uses a machine to actually measure the concentration of tiny particles outside the mask versus inside the mask.
Oh.
Yeah, it gives you a number, a fit factor, that has to meet a certain threshold. It removes all the guesswork. A certified fit test proves that the mask you've been given can physically seal to your face.
Fascinating. One is based on taste, the other on a particle counter. But a good fit test doesn't mean you're safe every day. What about those daily checks?
That's the seal check. And you could argue it's more important for day-to-day safety. The training says you have to do a positive and a negative pressure check every single time you put the respirator on.
Every time.
Every single time. The positive pressure check, you block the exhale valve and you breathe out gently. The mask should puff out a bit. If no air escapes, you have a good seal.
And negative?
Negative pressure. You block the cartridges and breathe in gently. The mask should collapse slightly onto your face.
Yeah.
If it stays there for a moment, the seal is good. The sources make it clear. This is non-negotiable before you go into a hazardous area.
And that right there is the actionable knowledge. The failure point for most people is just forgetting or
Yeah.
rushing through those two simple checks.
And then you're relying on compromised equipment. And that's not even getting into the cartridges themselves. Proper use also means knowing when to change your filters.
Right, they don't last forever.
Not at all. A chemical cartridge has a limited service life. Once the agent inside is saturated, it just stops working. The training talks about the end of service life indicator, or ESLI,
But what if there isn't one?
which is often the case. Then the rule is, if you smell or taste the hazardous chemical while you're wearing the mask, it means you've already been exposed. The cartridge is done.
So you get out.
You get out immediately and you replace it.
This moves us perfectly from personal defense to proactive defense. The gear is critical, but safety is more than just being defensive. So let's move beyond the PPE itself. What's the role of actually monitoring the environment, the air quality?
And that brings us to the third pillar of the training, air quality monitoring. The sources define this as a crucial proactive method.
Yeah.
Use it to identify potential hazards before they can do any harm or, exceed those PALs we talked about.
So the PPE is the barrier, but monitoring is the early warning system.
Exactly. It's constant surveillance. It confirms two big things. One, that the area you're about to enter is actually safe for the gear you're wearing. And two, that your engineering controls, like ventilation, are actually working.
So if a ventilation fan for a welding station dies, the air monitor is the first thing that's going to tell you that the fume concentration is spiking.
Precisely. It gives you the hard data to make safety decisions in real time. Can we keep working, or do we need to stop, fix the ventilation, maybe upgrade our protection? But what's really interesting is the specific language in the training. It says employees need to know how to monitor air quality if needed.
If needed. So it's conditional.
It's conditional knowledge, which raises a big question, right? What conditions mean an employee needs this skill instead of just, management handling it?
That suggests it depends on your role. It sounds like the sources are pushing certain workers to be their own first line of defense.
They absolutely are.
Yeah.
It points to this layer of active environmental awareness that's required in certain jobs, especially jobs where conditions are volatile or always changing.
So if you're on a fixed production line, maybe management handles it.
Right. The environment is predictable. But if your job is variable, say you're a maintenance worker going into a confined space, a storage tank that was just cleaned with a powerful solvent.
The environment is constantly shifting.
It's always shifting. You need that immediate active monitoring skill to confirm the atmosphere is safe right now at this moment before you go in. It puts the responsibility on that worker to use the skill to verify their own safety.
That's a huge responsibility. Can know when things have changed and when to stop work. It really turns the employee from, I guess, a passive participant into an active safety manager of their own space. So if we look back at the logical flow here, it's a clear three-step mandate.
Yeah.
The process starts with identification, know your hazard, dust, fumes, chemicals.
Awareness.
Then it moves to protection. Master the proper use of your mask, especially those fit and seal checks.
Application.
And the whole system is supported by that ongoing surveillance, air quality monitoring, used when it's required.
Awareness, application, and verification. That's the framework. And if we connect this back to the big picture, the value here isn't just knowing the hazards. It's understanding that the training is there to ensure that knowledge is applied consistently. Consistency in doing your seal checks, consistency in picking the right cartridge, consistency in knowing when to monitor the air. That consistency is the bridge from the knowledge to that one goal we started with.
Preventing illness and ensuring safety.
That's it. The training exists to eliminate the gaps that lead to failure.
Absolutely. Application is everything. And this leads us to our final thought for you to think about. Given that the source material emphasizes that this training has overlap with other workplace safety training topics, consider this. What specific mandatory safety procedure, something beyond respiratory protection itself, would be rendered completely useless if an employee failed to properly secure their mask? Think about the consequences in an emergency, something for you to mull over as you continue your own deep dive.